I don't have a mirror to see myself, but I'm covered in white plastic dust and powder. And that's the reason why we wear a mask and safety glasses, because if you look at the safety glasses, it's covered in plastic. And this is one that probably all these little dust particles could have hit my eye.
And your lungs.
Yeah, and I could have inhaled it too. Hey everyone, it's Mike from Hatch Duo, and today we'll be doing a slightly different segment where we're going to be doing a teardown on something I've been holding off on for the last, 2-3 months. What I have here is a water drop pre-sediment carbon block filter, and the model number is WD-G2CF. This comes from my reverse osmosis water filtration system at home, and I was due for a replacement. There was a reminder that came up, and rather than throwing this away, considering the amount of plastic, there's a lot of heft to this. Considering the amount of plastic, that's being used to make the filter, and also, this is a disposable item. And where does this end up? Likely either recycled or in your landfill. And so without further ado, why don't we dive right into tearing this down? All right, well, hello again. Now we're in Hatch Duo's lab. And what I hope to learn is how this was assembled from the factory and how it was all sealed up. My guess is that it was probably ultrasonically welded at some point in the assembly process. So we're going to find out and see what we learn from this, and see, maybe let's discuss on ways that this design can be improved for sustainability. What I'll be using today is my handy Craftsman all-in-one tool with a cutoff blade on it. I'll have my Phillips screwdriver in case I come across any screws in the disassembly process. And then, of course, anytime you're working around tools, safety first. So what I have here is my dust mask, which I'll be putting on, since we'll be generating a little bit of dust from the cutting, and safety glasses. All right, well, why don't we get started? So before I start, I'm gonna remove this cap. So this is just a decorative cover. I've taken this apart before, and I stopped because there's nothing else that can be removed. So what we have here, and from what I could see, is a bunch of residue buildup, and I suspect that's where the ultrasonic welding happened. And of course there's water leaking out. If you're an engineer or a designer or a product designer, it's important to do teardowns like these because you're learning from successful design. You're taking note of a design that's been produced, that's been validated, and you're able to take those ideas and learn from them and be able to apply them to your designs in the future. Well, this is the Dremel bit. Obviously it broke. Could be that the material just melted onto this and just released, but it'll be interesting to see what happened in slow motion on video. By doing a teardown, you're able to see different ways that an engineer or a designer thinks, not only from yourself, but you're able to interpret. You can ask the question, why did they design it this way? Maybe there's a reason why at the time. So that's the reason why I do teardowns quite frequently, is to see how other engineers think. And that allows me to apply those observations and learnings to our future programs, and help our future clients not only to save time, but also spend that time that we save on innovating the product itself. it's a good sign that water's pouring out. Earlier I said that I was concerned if the blade would be able to cut through the thick wall of the plastic, and I had some concerns, but sure enough, the blade was large enough to be able to cut through all the plastic. So let's see if we could pry it apart. Oh God, you're so close. Keep cutting. I found that doing teardowns like these helps me get through a lot of design roadblocks because you're able to navigate through how an assembly is put together. There's a reason why there's O-rings, where they are located. There's always a reason why design features are placed where they're placed. All right. So what I'm expecting to see is maybe some active carbon pellets in here, since this is a carbon filter after all. Wow, look at the wall thickness. Jeez. So there's another part in here. Let's cut it from the other end. Okay. Okay. So what I was expecting is that the outer housing would contain all of the active carbon elements, but in fact what they have here is a sediment filter, which is that foam that you see. What you see here is, so the inlet from your municipal flows through the water drop device, and then the water feeds into these two orifices on the side, and then comes out of this hole and then into the outer body. Because this outer body, this gap that you see, water fills it, goes through this sediment filter, which is like a mesh, maybe captures some micron level. You know, it's like acts as a pre-filter, and then it goes through and into the carbon filter that's in the middle, but it removes the impurities and flavor from the water with this filter and comes out of this spout. Things I like about it is that the carbon block and the sediment filter is contained. If I were to, as an engineer, if I were to consider redesigning the housing, I'd probably design it in. It already has two parts that's sonic welded together. I'd probably just make one side of the cap with an O-ring seal or a multi O-ring seal, and have it twist off to be able to access the sediment filter. Because I'd rather dispose of the sediment filter and the carbon block as opposed to all this additional plastic that's going into our landfill, that's going to waste. So, in a way to be more sustainable, that's my suggestion. I did find it interesting that they're able to achieve such thick wall thickness. I mean, this has to be at least, you know, a 3/8 of an inch thick, wall thickness, at least 5/16. Pretty impressive. This is injection molded because I see the ejector pin marks on this part. Can this be improved? Absolutely. I think that this could be the expendable item, the item that you replace, as opposed to all this plastic. I mean, look at how thick that wall is. I mean, it has to be, right, because it has to be fairly thick because it's holding a lot of pressure. Your municipality's water pressure is probably around the neighborhood of 60 psi, and so you can't have really thin plastic otherwise it would burst. So that's one of the reasons why they went with a thick filter. But I can imagine that this could be made out of maybe aluminum or stainless steel. And then probably I can imagine that this could be made out of food grade stainless steel at a much thinner wall thickness. And maybe a combination of plastic and stainless steel, or this assembly could be made in such a way that you twist it on, twist it off to be able to access the actual pre-sediment and carbon filter in a way that you're just producing less waste in the landfill. Overall, I think, what I mentioned earlier, this can be easily converted to like a twist-on part, a screw-on part, and then, have this inner part be a replaceable item. Well, everyone, I hope you guys enjoyed this teardown video. Let me know down below in the comments on what you would like to see torn down next, and shoot over some ideas, and I'd be happy to shoot those videos and keep them coming. All right. Well, until next time, let's hatch awesome.